Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. In the name of Allah, the most beneficent, the most merciful, all the praises and thanks be to Allah, the Lord of the mankind and all that exists. And may peace and blessings be upon our Prophet Muhammad sallallahu alaihi wasallam and upon his family and companions. A very good afternoon to distinguished professors and speakers, dear colleagues and students. It is our great pleasure to welcome you to the public lecture of the FSMVU-UII Joint Studio course in the even semester or spring semester academic year 2020-2021. As you may already know, my name is Lia Sharifah Ismailia Al-Atas. I will be your host for this event. And to start this public lecture, let's recite Basmalah all together. Bismillahirrahmanirrahim. Okay, so with us have already joined 115 participants, and in this public lecture titled Design Hackathon, TRIZ for Architectural Design, we will hear presentation from our invited speaker, Associate Professor Dr. Risdiyono from Department of Mechanical Engineering, Universitas Islam Indonesia. Dr. Risdi will share to you about the TRIZ, the design method or design approach for architectural design. So in this time, I would like to invite Dr. Risdiyono to give his lecture. Please, Dr. Risdi, time and screen is yours. Thank you.
Okay, thank you very much. So let me share the screen first. Okay, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Alhamdulillah, assalatu wassalamu ala rasulillah, la khawla wa la quwata illa billah, wa ba'd. Okay, thank you very much, Ms. Sarifah, for the opportunity. So this afternoon, I would like to share a little knowledge that I have related to TRIZ. And because the limited time, maybe I just want to share introduction about TRIZ, okay, and how to apply this method in architectural design. My name is Risdiyono, so you can call me Pak Risdi. Okay, and currently I am the head of Mechanical Engineering Department, Islamic University of Indonesia. And I also the president of Indonesia TRIZ Practitioner Association, or we call it INTRIZ, okay, Indonesia TRIZ Practitioner Association. You can go to www.intriz.org. My background is mechanical engineering, so I got my bachelor from Gajah Mada University in mechanical engineering. For Master of Engineering and Doctoral of Engineering, I got from Asian Institute of Technology, Thailand. And this is my email address. If you want to discuss more, you can contact me, risdiyono@uii.ac.id. This afternoon, we will discuss three main topics. The first one is about introduction to TRIZ. The second one, the practical example, how to use TRIZ in problem solving. And the last thing related to TRIZ for architectural design. Okay, even though I am a mechanical engineer, but maybe this afternoon we will discuss about architecture. Okay. Let's start with the first part, introduction to TRIZ. Maybe some of you already know that TRIZ is a problem-solving method. So if we want to know about TRIZ, we have to know first what problem is. Okay. I have the quote of the day, okay, for this afternoon from Taichi Ono. he said that having no problem is the biggest problem of all. So this quote is very important in TRIZ, because TRIZ is a problem-solving method. So if we have no problems, it means that we have nothing to solve. Okay. Let's see an example here. So if we see this photograph, and then I ask you, is there any problem here? If you say that there is no problem, actually this is the big problem. Okay. If you cannot identify that there are many problems in this picture or in this situation, and then we have a big problem, because we cannot identify the problem. If we cannot identify the problem, it doesn't mean that there is no problem. Actually, there are many problems related to architectural here, related to environment here, related to mechanical here, related to social, related to economic, and so on and so forth. So actually, knowing the problem is the important thing before we try to solve it. Okay, so no problem is big problem, because we are not able to see the problem. That's why I agree with Taichi that no problem is big problem. Okay. And then what is problem? There are many definitions about problem. And this afternoon, I would like to pick one of them that's related to what we'll discuss. Problem is undesirable gap between reality or current state and intended condition or desired state. So if we have a gap that is undesirable between the reality or the current state with the intended condition or desired state, then we see there is a problem here. Okay, so for example, this one, okay, this is the current state. And actually, we have undesirable gap here, because actually we do believe all of us will have the intended state, okay? Before that intended state is achieved, and then we still have a problem. And how to fulfill the gap is a problem-solving method here. Okay, so here, problem, like what I said before, there are many definitions. But today, I would like to use this definition, that problem is undesirable gap between reality or current state and intended condition, okay, or desired state. So in many cases, okay, problem become the trigger of innovation. So problem is opportunity. You can see maybe in the current condition, we have like a COVID-19 pandemic. Okay, we see that we have a big problem, but actually there are many opportunity, okay, behind the problem. Okay, we can see, yes, there are many people affected by this condition, but also we can see that many opportunities are open because of this problem. Okay, so we can see, for example, the online shopping is increasing, and many new like young people, okay, become more experienced with the business, and so on and so on. Okay, so in many cases, problem become the trigger of innovation, because problem is actually opportunity. And then when we see what the World Economic Forum recommended, okay, about the growing skill, when we compare in 2015 with in 2025, we have the 10 important soft skill that we have to master in, okay? In 2015, we can see there are many things related to complex problem, critical thinking, creativity. And in 2025, we add some more. Number 1, analytical thinking and innovation. Number 3, creativity, originality, and initiative. Number 5, critical thinking and analysis. Number 6, complex problem solving. Number 9, reasoning, problem solving, and ideation. You can see here that there are many growing need related to analytical thinking, related to problem solving, and ideation. Why? Because these skills are still not replaceable by automation, technology, and robotics. Okay. Most of them are related to problem solving, innovation, creativity, critical thinking, and ideation. Okay. The question is that do we have a systematic tool to improve our creativity, how to improve our innovation and problems solving skills? So this is the question. Do we have any systematic tool? Because this is the thing that we need in the future, but we don't know whether there is a systematic tool to improve this one or not. So that's why this afternoon I would like to introduce one of the tools to improve these things. I'm not saying that TRIZ is the only one, okay, systematic tool to improve these things, but actually TRIZ is just one of, okay, one of systematic tools available. You can try to find out another systematic tools, but because I am currently the president of Indonesia TRIZ Practitioner Association, then I would like to introduce you this TRIZ. Okay. This is Henrik Atzuler, the founder of TRIZ methodology from Russia. Okay, he said that creativity can be learned, just like engineering problem. Okay, just like exact science. Okay, so he wrote a very interesting book entitled Creativity as an Exact Science: The Theory of the Solution of Inventive Problem. Okay. The original book is in Russian, but we have the English version. So if you want to know more related to the his book, you can try to find out in the Google. Okay. So he said that even if you are not really talented, when you practice every day, you still can be a good music player. Yeah, he believes that a music player, there are two type of music players. The first one is talented person because he has a talent and then it's very easy for him or for her to learn, so very quick. But if we are not talented, we can still be a good music player, but maybe need more time. Okay, the difference is just about the time. The talented person may be very fast in learning, but if not talented person, maybe we need more time. What is TRIZ? Okay, TRIZ is the acronym of a Russian language. Okay, Teoriya, Resheniya, Izobretatelskikh, Zadatch. Or in English, usually we call it TIPS, Theory of Inventive Problem Solving. But in order to keep the originality of the word TRIZ, so we always use TRIZ instead of tips. So in many formal occasion, we will always use TRIZ, okay, because TRIZ is the original name of this method. The concept of TRIZ is like this, okay? Somebody, sometime, somewhere has already solved your problem, okay, or similar, yeah, to it, okay? So if we face a problem, we have to believe that somebody, we don't know who, okay, sometime, we don't know when, and somewhere, okay, has already solved the problem. They have the same problem with us or something that's similar to our problem. Creativity means that finding that solution, okay, and adapting it to the current problem. So creativity actually that how to find that solution and adapt it to the current problem. Maybe what we face today, okay, is similar to what someone else faced maybe years ago. Okay, and he or she already solved the problem. Okay, so the thing that we have to know is how they solve the problem. If the problem is similar, maybe we can adopt that solution into our problem. Maybe the problem in mechanical engineering, okay, also similar with the problem in architecture. So if one of our college in architect, for example, has already solved the problem, maybe I can adopt that problem, the solution. Maybe just only the object is different, because for architecture, maybe the problem related to buildings, okay. For mechanical, maybe related to machine, or maybe related to manufacture and so on. But actually, the problem might be similar, just the object is different. Okay. So by having this belief that somebody, sometime, somewhere has already solved our problem or one similar to it, and then we have to know where. Okay, we can see, we can get the data of good solution. If somebody solved a very important problem and he or she got a very good solution, and then it makes sense that he or she, okay, patent it. Okay, so they will register to the patent. Means that if we want to know the collection of good solutions, okay, we have to go to the patent database. Patent database is a place where we can get the data of very good solution, because only good solution is patented. So if you want to know the solution of problems, okay, we can go to patent database. Okay, and then find the solution there. Okay, but maybe it's time consuming. Okay, it's not very easy. Okay, to access the patent database. But how we can get the solution without seeing, without visiting the patent database? Okay, then what Atsuler has done is like this. So Atsuler evaluated, okay, more than 200,000 patent. He and his college, okay, analyzed the patent worldwide, more than 20,000. Okay, it's not a simple task. It's very, very big task. And then he synthesized those patent, okay, just to 40,000 innovative patent. So actually, patent, okay, we can classify into five. Okay, just simple patent to breakthrough patent, and then Azure try to find out the innovative patent. So not just a small innovation, but a very big, very important innovation. Based on this 40,000 innovative patent, and then he mined more, okay, and then get the theory of inventive problem solving. So TRIZ is invented by analyzing the pattern. Okay, so this is very important to help us. We don't need to go to the patent. We just follow the theory that he has invented, and maybe it will help us to find the good solution. So these are the key discoveries that Eschuler invented. First, he discovered that there are 40 inventive principles for solving problem. So there are so many patterns, but actually he can summarize, okay, all those solutions into 40 only. So if we want to see the principle, okay, that used by the inventor, we can see from this 40 inventive principle. Okay, So this is very important, and this is the best discovery that he found. Okay, about 40 inventive principles. The second one, trend of engineering system evolution. Okay, he found that there are evolution. Okay, in engineering system, trend to become more ideal. So every product will be more ideal, become more ideal and so on. You can see, for example, mobile phone. Okay, mobile phone. You can see the trend of mobile phone before long time ago when mobile phone was invented. The mobile phone is very big, and also the function is very limited. Okay, just only to call. Okay, and the battery is very big, and the weight also is a problem. But now you can see mobile phone is very ideal. Why? Because many things we can do by using our mobile phone. You can compare to maybe 10 years ago or 20 years ago, the ideality of the mobile phone we can see clearly, because in TRIZ, we believe that engineering system, everything, the product that we make will have the evolution stage, and this become more ideal and so on. And the third one is scientific effect. This means that we have to find out how to solve problem, not only okay in our field of study. For example, if my background is mechanical engineering, it is better okay if I have problem, not only try to find out the solution from mechanical engineering perspective, but we have to find out the solution maybe from other perspective, maybe from chemical, or maybe from electrical, or maybe from architect, or maybe from environment, and so on. Means that this will make our view become wider and wider. Not only try to find out the solution on our domain, but also in other domain. Okay. This is actually the key discoveries, or I can say three of key discoveries that he found. Actually, he has more than five discovery, but I think this three is very important that we have to know. And maybe these three things, you can use it as the keyword if you want to know more about TRIZ. Okay, you can type this in the Google, okay, and then you will find many things related to this. For example, if you just type 40 inventive principle of TRIZ, and then you will direct it to the website that related to this one. Or maybe you type trend of engineering system evolution, and then many articles related to these things. Okay. So what Altshuler did, okay, first he analyzed the pattern, okay. Based on this pattern analysis, he construct the theory that what we call as TRIZ. Okay, so he construct the theory based on pattern analysis. After he construct the theory, and then he used the theory to solve the problem, means that he validated the theory. Okay, he tried to use the theory to solve the problem, and then he patented the solution into the patent office, and then he got the new patents. Mean that the method that he used has already successfully to create or to generate more patent. So if Altshuler has already successful to use the TRIZ, mean we can also use TRIZ as a tool. Okay, how to generate idea, how to generate solution, and then maybe we can get the patent from that solution. So based on that introduction, we can see that TRIZ is a systematic problem-solving method based on logic and data. Why based on logic and data? Because we use the patent database, okay, and not intuition or spontaneous creativity of individual or group. So Altshuler believes that everybody is creative. Okay, so creativity can be learned. If we feel that we are not creative enough, maybe because we do not practice. Okay, so by using the method, just follow the step by step, maybe we can be more creative. Okay, I know TRIZ, okay, since 2011, okay, when I visited the uh, Malaysian TRIZ workshop here. That is that was in November 2011, and this is Professor Sergey Ikovenko from MIT, USA. At the time, he was the president of International TRIZ Association, and I learned TRIZ from him directly, from level 1, level 2, and level 3, and he certified me also. So I learned TRIZ from Sergey Ikovenko, Professor Sergey Ikovenko from MIT, and he is the direct uh, uh, student of Atsuler. So he learned TRIZ from Atsuler directly, and then I learned TRIZ from Sergey Ikovenko. Okay. For me, there is a tool for creativity, innovation, and problem solving. And currently in Indonesia, the on right now currently just only one who are in the third level of TRIZ certification. So in international TRIZ, we have level 1, level 2, and level 3. Okay, and you can find in the Matriz website. Okay, you can find for Indonesia, very limited person who are certified, okay, for TRIZ. So that's why I'm happy today to share the knowledge about TRIZ, so that there will be many more people in Indonesia will be interested in TRIZ and learn TRIZ, and then maybe got certification in TRIZ. So it is my pleasure to share the TRIZ, and if you want to know more about TRIZ, you can contact me. Okay, because we have training also and certification. You can get a certification level 1 and level 2 from Indonesia. Okay. So here, the certificate of instructor. So I can be the instructor of TRIZ training, and I have the right to give a certificate. Okay. Let's see what the theory of inventive problem solving is. Okay. You see here, I highlight inventive problem. Okay, with the yellow highlight. That means that inventive problem is one word. Okay, so theory of inventive problem solving means that we will solve the problem that is inventive. Okay, what is inventive problem? Inventive problems has characteristic, that is the problem with contradiction. So if we find a problem with contradiction, okay, we can call it as inventive problem, because usually it's very difficult to solve. When we improve one parameter, and maybe another parameter will be degrade, means that this is a contradiction. Okay, and solving this problem usually will lead to notable invention. Okay, so let's see. For example, this is in mechanical engineering case. Okay, if we increase, okay, the power, sorry, yeah, if we increase the power of the car, then the speed will be improved. Okay, and speed improve is something that we like, but the fuel consumption will go up. So this is the thing that we don't like. So here we have a contradiction. If we want to increase the speed of this car, then we will get the bad impact. We will get something that we don't like. That is the fuel consumption. So this is what we call inventive problem. When we improve one parameter, and maybe another parameter will be worsened. So in this case, if you can solve this problem, if we can make a car that the speed is okay, but the fuel consumption is reduced, and then we do believe that that technology will be easily patented. Why? Because this is very difficult to get a very fast car with a low fuel consumption. So this is what we call inventive problem, or problem with contradiction. Or maybe another contradiction we can see here. Okay, the table must be big, okay, to serve many people, and must be small to pass the door. Okay, we have a contradiction also here, because in one condition the table should be big, but in another condition the table should be small. Why the table must be big? Because we need to serve many people, so that the size of the table should be big. But why the table should be small? Because we need to move the table, so that we need this is small, so that the table can pass the door. This is the example of contradiction also. If we can have something that maybe can be big in one time and can be small in another time, that will be the innovation. And maybe most of us now see many transformable furniture. The furniture that can transform, it can transform from small to big, or can transform from a table to the bed, or from bed to the chair, and so on and so on. So this is the innovation, okay, that we can see many of new manufacturer, okay, they manufacture, they introduce what we know transformable furniture. Okay, so you can just type in YouTube, and then type like transformable furniture, and you will see many products right now that available in the online market. So this is the characteristic of inventive problem. Traditionally, the problem is addressed by compromise, sacrifice, or trade-off. Okay, so if I want the car, okay, with the high speed, okay, we have to compromise. Okay, so that, okay, this is because we need the speed, and then we have to accept, okay, the high consumption of the fuel. Okay, or maybe sacrifice. Okay, if we want to make the low consumption of the fuel, and then we sacrifice the speed, and so on. Okay, how about TRIZ? TRIZ resolve contradiction. So what TRIZ try to do is how we have the car that very fast but low fuel consumption. This is the concept of resolving contradiction. We don't use compromisation, we don't use optimization, we don't use trade-off, we use a resolving contradiction. Okay. The question is how to solve problem by using TRIZ method. Okay. TRIZ does for problem solving and forecasting, like what algebra does for equation problem solving. So I do believe all of us have learned about algebra, okay, especially for equation, okay, in high school, I do believe. For example, if we have this specific problem, okay, 3x squared plus 5x equal minus 2. And the problem is find out x, okay, the value of x. Okay, this is a specific problem. Okay, what we will do to solve this one, if you use trial and error, okay, this is very, very difficult. Okay, you try to replace x, for example, with 0, or x with number 1, number 2, and so on. Okay, and then it's very difficult and very long. Okay, what we will do, usually we will standardize the problem. Okay, we do analyze, okay, so that we will have the the new equation. Okay, 3x squared plus 5x plus 2 equals 0. This is the standardized problem. Okay, and then we will model the problem. We replace 3 by A, okay. We replace 5 by using B, okay, the parameter B, and then we use C to replace number 2. So we will have general problem. Okay, ax squared plus bx plus c equals 0. This is what we call general problem by using the model of the problem. And then by having the tool, we will have the general solution. Okay, so we will have this equation. Okay, I do believe all of us know this equation, how to find x1 and x2. Okay, by having this general solution, and then we will replace b with the specific number. B with 5, okay, and then A we replace with number 3, and then C we replace with number 2, okay, and then we will have the solution that x1, okay, equal -1, and x2 equal minus 2 by 3. Okay, this is the specific solution. Okay, this method in the algebra, okay, is very popular. Okay, so if we have another specific problem, okay, when we have a new specific problem, yeah, just follow this one. For example, if you have 4x squared plus 7x equal 10, for example, and then you know the value of A, the value of B, and the value of C. And then just go to the general solution, and then we will have x1, x2. If we have another problem, just use this method, and then you will get the solution. Okay, so having this method in mind will help us, okay, to solve the problem by using TRIZ, because TRIZ have the similar method. Okay, in TRIZ we adopt algebra. So if algebra have something like this, and then TRIZ approach also the similar thing. We have specific problem, and then we analyze the space problem. We standardize the problem. Okay, we get a standardized problem. By having a standard problem, and then we will model the problem, okay, to get the general problem. And then trees have tool to solve the general problem. Okay, general solution will be available by having the trees tool. Okay, if we have general solution, and then we will get specific solution. So this step is exactly the same with this one. Exactly the same. We have specific problem, and then we make the problem become standard, and then make the problem become general. Okay, and then we will use the general solution. Okay, based on that solution, general solution. Okay, we apply the solution into our specific problem, so that we will have a specific solution. Okay, so this is how TRIZ approach. Okay, and we will try to find out the example, the practical example, how to use this method. Okay, I prepared the basic example that you can find in many reference, okay, related to this one. So, for example, we have specific problem like this. Okay, we need to have strong fast, okay, for safety reason. Okay, but we have problem with the weight. So this is the fast for fighting, okay, for war, okay. You can see here the function of the fast is to protect, okay, the user from sword, maybe, or from arrow, or spear, and so on. Okay, so if we want to make the fast become stronger, and then we have to make it thicker. But when we make it thicker, we have a problem with the weight. Okay, so this situation we call as a specific problem. And then a TRIZ will standardize the problem. Okay, for example, if we use one of TRIZ method by using this is engineering contradiction. So in TRIZ we have many methods. One of them we call engineering contradiction. So we standardize the problem by having engineering contradiction. You construct the problem into this format: if, then, but. Okay. So this is the format of TRIZ that you have to familiar with. Okay, if, then, but. This is the standardized problem. So if in the TRIZ, okay, you see this if, okay, and then will be followed by then and but. So if, yeah, we make the fast thicker and then it will be stronger. This is the positive thing that we get. Okay, after we modify this one, when we modify the thickness and then we get the positive thing, that is the strength, but it will be heavier. Heavier means this is negative because we don't like heavy. We need something that not heavy. Okay, but we need a strength here. So here we have the positive things, but in the same time we got the negative things. So this is what we call contradiction. And in TRIZ, we construct this as standard. Okay, if, then, but. So if you learn TRIZ, we will be familiar with this if, then, but. I do believe that in architecture, okay, well, we can construct many problem into this format, if, then, but. Okay, for example, if for example, the problem is that the space that we have is very limited, and then you have to construct the building. You need more space. The solution will be like the number of floor. Okay, the height of the building. Okay, if we make the building higher, then okay, it will give us more space. But for example, we have problem with the maybe the light, for example. Okay, so this is the standard problem that TRIZ construct if, then, but. We have four standard problem. Okay, if you want to know more, okay, you can just try to find out the how to standardize problem in TRIZ. And then we have engineering contradiction, we have physical contradiction, we have substance field modeling, and so on. Okay, at least we have four. Okay, but in this presentation, I just want to give you a brief idea how trees work by using one of a standardized problem here, what we call engineering contradiction. Okay, how to solve this engineering contradiction? Okay, you can see here number 3, we have a tool here, the tool. Okay, what the tool trees have. Okay, here tool here. Okay, if we have this problem, this is what we call engineering contradiction, or easy. Okay, if we have the problem something like this, and then TRIZ will give you a tool. Okay, how to solve this contradiction. Okay, so what tool that TRIZ have for solving this contradiction? TRIZ has the the contradiction metric. So if you want to use contradiction metric, you have to know first what is the improving parameters and what is the worsening parameter. Here, the improving parameter is the strength, because it will be stronger. Stronger means something that improve. Okay, but it will be heavier means something that worsen, because we don't like. So in this case, improving parameter is strength. Okay, worsening parameter is weight of a moving object. Okay, so the problem is that general. I want to improve the strength, but I don't want to get more weight. So here, now we are not talking about fast anymore. Okay, we are not talking about the fast anymore. We are talking about general. I have something. Okay, not only the fast. Okay, but the problem is I want to improve the strength, but I don't want to get the product heavier. So what is the product? It's general. Okay, maybe helmet, maybe car, or maybe like helicopter or something like that. Okay, so this is general, like ax squared plus bx plus c equals 0. Okay, so we don't know the A, B, C, but we can replace A, B, C with a specific number. This means that we generalize the problem. We generalize the problem that I have something that I want to make it stronger. Okay, but I have problem with the weight. Okay. So by using the engineering contradiction, okay, we use contradiction metric, and then we will get a general solution. This is the contradiction metric. In the left side, we have improving parameter, and in the up side, we have the worsening parameter. So improving parameter is the strength, okay, and the worsening parameter is the weight of the moving object. By having this, sorry, yeah, by using this metric, contradiction metric, okay, we will see the solution. Okay, so this is the solution that yeah we have 1, 8, 40, and 15. And 1, 8, 40, and 15, this is related to 40 inventive principle. Okay, so we have this one, 1, 8, 40, and 15. Okay, in TRIZ, we have 40 inventive principle. So what is the solution if I want to improve the strength, but I don't want to get the weight worsen? So the solution is principle number 1, principle number 8, principle number 40, and principle number 15. This is the general solution for the general problem. What is the general problem? I want to improve the strength, but I don't want to get the weight become worsen. So this is the general problem. What is the general solution? Principle number 1, principle number 8, principle number 40, and principle number 15. Okay, and then we just see what principle number 1. Principle number 1 is segmentation. How about principle number 8? Number 8 is anti-weight or counterweight. Number 15 is dynamics. And number 40, composite materials. So the solution, the general solution of our problem, if I want to improve the strength without worsening the weight, this is the general solution. Make it segmented, okay, means segmentation. Or we use anti-weight, okay, or use the principle of dynamics, okay, or we use the composite material. So, okay, this is what we call the general solution. This is not only for the fast, this all for all, okay, including, for example, you want to to design the table. The table should be strong, okay, but the weight should be not worsen. So you can use this one. You segment the table, okay. You use the dynamic table, or you use the composite table, and so on. So this general solution. So the general problem is that we improve the strength, okay, but we don't want to get the worsening parameter weight of moving object. So the recommendation is segmentation, anti-weight, composite material, and dynamics. And like what I said before, this is applied for general, okay, not only for the problem we face related to the fast, but also for other problems. For example, you can say, I want to make the table stronger, okay, but I don't want to make the table heavier. So you can use this one also. Or maybe car. I want to make a car stronger, but the weight of the car is not worsened, or something else. Okay, so this is the recommendation if we have the a general problem. Okay, now we come to specific solution. Okay, number 5, specific solution. The recommendation is segmentation, anti-weight, composite material, and dynamics. Okay, so how if we apply the solution into our problem? Our problem is about the fast. So how to make the fast, okay, stronger, okay, but not heavier. So how if we use composite? Now it's very popular, the Kevlar, okay, used for policemen, okay, in army and so on. This is very light, okay, but very strong, okay. So this is one recommendation about composite materials. So if I want to have something that is strong, okay, but not heavy, you can use composite. It's only for fast? No. It's also for table. It's also for example, aeroplane. So you can see aeroplane now become more lighter because the composite materials. Okay, so when we see here, we have four recommendation. Okay, you can come up with any one of them, the solution of your problem. Our problem is related to the fast, and then the problem is that how to make the fast stronger, okay, and then without becoming heavier. Okay, so we use composite material, and then maybe we can come to another solution. How about anti-weight? So before you apply this concept, you have to know first what anti-weight means. So you can try to find out the meaning of anti-weight for the inventive principle. By having that definition, you will see that anti-weight means that you transfer the weight to something else that having the capability of holding those weight. Okay, you can use, for example, the balloon. Okay, you connect the fast to the balloon, I think, but this is not the practical. Okay, yeah, maybe you can use this concept by exoskeleton. Okay, so the weight of the fast will not be held by the body, okay, our body, but something else, the skeleton. And this is the concept of exoskeleton. So we don't have any problem if even though the weight of the fast is very high, no problem, because the one who will take care of the weight is not our body, but something else. That is the exoskeleton. So that's the idea. How about if we make the solution of this problem by segmentation concept? Okay, before you apply segmentation, you have to know first what the meaning of segmentation. Okay, without understanding the meaning of segmentation, it's very difficult to apply this concept. Okay, segmentation means that you make the product segmented. Okay, for example, like this. Okay, you can make the facial segmented. In one segment maybe thicker, okay, because to protect a very important tissue, for example, to protect the heart, to protect the kidney, and so on. That is very important body part. Okay, so you make it thicker, or maybe you don't need. For example, in this area, we don't need because usually we the sword come to this area, and so on and so on. So here we don't use the full of protector, but the important part that usually we got attack, okay, will be protect more, and the part that usually we have no problem, maybe we don't need to use protector there. So this is the meaning of segmentation. So we will get the good solution, means that the protector will be stronger, but the weight is not the problem anymore. Okay, so this is the segmentation. And how about if we use the concept of dynamics? Similarly, before we apply the concept of dynamics, we have to know first what the meaning of dynamics means. That you have to know what dynamic is, so that you can apply to our situation. Okay, dynamics mean that it's not static, it's moving, okay, easily moving. So you can see something like this. This is the protector. Okay, I do believe you like this guy. Okay, because he is a hero, okay, a hero in the movie. Okay, I don't know in the real life, but most of movie commentators say that this movie is very uh, interesting. Okay, so this is the concept of dynamics. When you need it, and then you just call those protector, and then all those part will come to you in a minute. Okay, so this is the concept of dynamics. Mean that we have the problem how to make the fast better. Okay, and we have four recommendation, and each recommendation we see how to implement those recommendation. Okay, so now it's 2 o'clock already. Oh, I have
Yes,
how
sir.
many minutes more, Bu Sarifa?
Yeah, actually, you still have about 20 minutes.
Oh, 20 minutes. Okay.
Yes.
Because I still have another presentation slide related to how to implement this into architecture design. Okay, thank you. So I do believe now you have a general idea, okay, how to implement TRIZ. Okay, we have specific problem, and then you standardize the problem, and then make the problem general, and then you will get the general solution based on the general solution or general recommendation, and then we will have a specific solution. Okay. So let's move to another example. Oh, okay. So based on that example, we see that inventive problem can be codified, classified, and solved methodically, just like other engineering problem. This is what Archulor said. Okay. So this is another example, maybe related to architectural design. Okay. You see here, okay, one of sport, okay, diving. Okay. Usually, this is what we do in diving. Okay, a dive has many phases. The first one is takeoff. Okay, the first one here, you jump up to gain the height. So you here, and then you jump out to get the height, and then you dive to spin. You make acrobatic movement here, and then you go to the water. Okay, entry the water with minimal splash. This is what we do in diving. Okay, and then the judge will score each diver. Okay, um, with a point, maybe maximum 10. Okay, based on the degree of difficulty. Okay, so here we have some contradiction. Okay, what the contradiction that we have here? So the platform need to be high for better style. So if the platform is high, and then you can do more style. Okay, but remember, if the platform is too high, and then it's dangerous, because when the diver enter the water, it will be danger. Okay, so in one time we need the platform become high. Okay, so that the diver will have more style. But in other hand, we need the platform become low for safety reason. The lower the platform, the safer for the diver. Because if the platform is very low, whatever the style that you make will not be danger for the diver. Okay, but imagine if the platform is very high, and then you enter the the water. Okay, and maybe our stomach come first. Okay, this will be yeah, I cannot imagine what the hurt that we will get. Okay, so this is the contradiction. Okay, the platform need to be high, and the platform need to be low. uh, if we use optimization method, we will compromise. Okay, we will find the maximum height that is still safe for jumping. Okay, and based on the statistic, we know that maximum is 10 meter. This is the optimization. More than 10 meter, it will be danger. Okay, so for this case, what we will get just only the maximum height. Okay, no innovation. TRIZ method resolve contradiction. Yeah, the board platform might be higher, but still safe. How to solve this problem? Similarly, yeah, we have specific problem, and then you standardize the problem. We will get the general problem and general solution, and we will get the specific solution. In this case, we have the physical contradiction. The platform should be high, the platform should be low. Okay, how to solve this problem? Similarly, this approach. But if you want to know the detail, I will give you more detail, but not in this time, because we have very limited time. But if you follow this, and then you will get the solution. What is the TRIZ solution? The TRIZ solution is soften the water. Okay, we make the water become softened. Okay, how to soften the water? We have to know the characteristic, the parameter of the water. For example, the water have the surface tension. How to remove the surface tension? The water has the uh, uh, another parameter, for example, density. How to make the density become lower? So if the density become lower, and then the water become softer. Okay, so this is the solution. Okay, by introducing the bubble. Okay, if we introduce the bubble from the bottom of the pool, and then what will happen? The bubble will go up. Okay, will go up, and it will break the surface tension, and also it will make the density of the water become lower. So this bubble also will make the mark on the surface become white. Okay, so first it's easy for the diver to get the target where will he or she land in the water, enter the water. And the second one, the surface of the water, the tension, the surface tension become lower, because break by the air. Okay, and also the density of the water become lower, because instead of just only water, we have air there, or void. Okay, so this is the sparkle system, and this is patented. You see here, by using the TRIZ method, we can invent new invention, how to make the higher platform without make the diver into danger situation. So here is the example how trees work. Okay, in the diving problem. Okay. So how does TRIZ come up with the idea softening the water? Yeah, because we have the systematic approach. Not only come up with the innovative person, but everybody, if he or she follow the step-by-step of TRIZ method, he will get the solution idea about having this bubble. Okay. Softening water for diving is example of TRIZ inventive principle number 35, parameter change. So you can see here what Asuler did. Actually, he found 40 inventive principle based on the pattern analysis. Okay, so if we know 40 inventive principle, that is a good start. Okay, good start for us. Okay, to know about trees. Okay, this is 40 inventive principle from segmentation, taking out local quality to composite material or structure. You can find this in the for triz40.com, and then you will get the explanation one by one very clearly. Okay. All invention will always consist of one of some of these 14 inventive principles. Okay, and today more than 2.8 million patents have been analyzed and investigated, but the number of inventive principles is still the same. So 40 inventive principle is very powerful, because even though we now already analyze and investigate more than 2.8 million patents, but we cannot add another principle. So 40 inventive principle is very powerful. The last presentation of my today presentation is about trees for architectural design. Okay, I will introduce you to Dr. Arif Wismadi. I do believe you know him. Okay, Dr. Arif Wismadi is my colleague in architecture department, who is very very good. Okay, in supporting trees uh, in Indonesia. So he is one of my friend in TRIZ, and he has done many projects related to TRIZ. And this one of his project with his student. I don't know, Dr. Arif Ismadi joined this meeting or not. If yes, thank you very much. Okay, so this is an example of what he has done with his student related to the problem of architecture problem. So limited space of land force us to make the building higher and higher. Okay, so this is the case in Vietnam. Um, so we can see here the problem is related to the taller building, and the distance between each building is no distance, zero distance. And the problem of this is about related to the light. Okay, if we have a taller building and then we can have more room, okay, but we have the problem with the light. Okay, that is the problem. If then but. Okay, and what he has done is the design of this one. Okay, you can see compared to this one, the design of this and this one. He tried to get the light from the upper the roof. Okay, and then he simulate how the circulation of the air and the light. Okay, and this is the example, just example how trees implemented in the architecture. And he wrote many paper related to this one, yeah, in proceeding, in conference, and so on. You can ask Dr. Arif if you want his original paper. Okay, and if you go to TRIZ journal, you can find out many articles related to TRIZ in architecture. Okay, this is using TRIZ in architecture. First step, this very old paper um, written by Darrell Mann. Okay, that's from UK. I met him many times with Darrell Mann, and he is one of very popular trees master. Okay, Darrell Mann. Okay. Uh, this is just example that actually the implementation of trees in architecture is started many years ago, but maybe in Indonesia we have very limited paper related to trees in architecture or trees in many areas, even in mechanical engineering itself. Okay, and then this is maybe a very new paper, trees as a problem-solving approach for architectural design education, the case of Jordan in the from University of Jordan. You can download full text PDF because it's free. I downloaded it already, and if you want one, you can download by yourself, or maybe you can just text me, and then I will give you the PDF file. Okay, what I'm trying to deliver here is that I want to share with you that the implementation of trees in architecture actually many people have done. Okay, and Dr. Arif is one of them in Indonesia. Okay, I do believe that if our university okay become the office of INTRIZ, because the office of INTRIZ is actually in our university in Islamic University of Indonesia, and we can apply trees in many area, again not only in mechanical engineering or in architectural, but also in psychology, in management, and so on, because actually trees can be implemented in many areas, even for the religion. Okay.
Kemudian untuk tugas syarat atau kafeterianya memiliki konsep yang berlanjut.
Okay, so this is the 40 inventive principle. Okay, and I want to just give you a brief example for the inventive result in architecture. So for example, segmentation. This is the meaning of segmentation. Okay, divide an object into independent part. Make an object sectional for easy assembly and disassembly. Increase the degree of objects fragmentation and or segmentation. Okay, and so on. So this is the meaning of segmentation. So you can see this example, segmentation. Okay, so you want to take this knockdown furniture, okay, from department store. Okay, and it's very easy for you, okay, to bring home because it's very easy when it is knocked down. So after that, you can assembly by yourself in your home. Okay, and this is another example, and so on. So in architecture, I think same thing. When we plan, okay, for like the landscape, okay, we will segment the landscape into, for example, business center or factory, working class housing, middle class housing, a commuter zone, and so on. This is what we call as segmentation. Taking out, taking out. What is the meaning of taking out? You just take the important thing that you need, okay, or you take something that dangerous, okay, from object. For example, this one, if I want orange, actually what I can take out is the orange itself, okay, the water, okay. So we can have the orange water. Okay. In orange water, maybe we can take what actually what we need. Maybe vitamin C. Okay. So that we have another product that we take out the vitamin C from this thing. So in architecture, for example, yeah, we know this one. I think. Okay. The criminal. Okay. The criminal, the dangerous person. Yeah, you take it out so that we have Nusa Kambangan, for example. Nusa Kambangan is the concept of taking out. You take the dangerous person to special places so that will not danger for others. Okay. Asymmetry, you make change the shape of an object from symmetrical to asymmetrical. Okay, if an object is already asymmetrical, increase its degree of asymmetrical. So you can see this scissor is asymmetric, but this one is more convenient compared to the symmetrical one. This one also, now we can see many of fashion designer, okay, make the design of fashion asymmetry because a long time ago, maybe most of our design of our fashion is symmetrical. Okay, and in architecture, you can see now many asymmetrical design. If you see before, maybe Joglo, okay, Joglo is very symmetrical. You can see Borobudur is also very symmetrical. So many design in the past is symmetrical, was symmetrical, but now you can see many new design in architecture are symmetrical. The other way around, okay, means that invert the action used to solve the problem. For example, before our body is moving and the street is not moving, but here now the street is moving and our body is static. So we don't move. Our position is here, but this fitness tool, okay, make different way. So the other way around. Okay, and we can adopt this one also in the swimming pool like this. Before we have a very big pool, and then we move our body, okay, to move from one corner to another corner and so on. But now we can make the swimming pool become smaller. Okay, our body is not moving, but the water is moving. Okay, but I try to find out this in Indonesia. It's not available yet. Okay, actually I need one. Okay, in my rooftop so that I don't need to go to swimming pool for swimming. Okay, curvature. I think we know the meaning of curvature, and this is the architecture design that now more uh, uh, flexible, okay, and the shape is curvature. Okay, you can see our airport, okay, Terminal 3, for example, also curvature. Dynamization makes something become more dynamics. Okay, for example, this is design of lamp or and so on. This now become more dynamics. Okay, and this is the dynamic building in Dubai, the world first rotating shape shifting tower in Dubai. So this is dynamization in architecture. And yeah, this is the maybe because we have no time. Okay, I think this is just introduction how TRIZ in architecture. Okay, I will close my presentation, even though I still have some another example, but maybe in the question and answer.
Yeah.
Okay, thank you.
Thank you, Dr. Risdi. That's very
Sarifah.
interesting presentation. So, okay, our students and colleagues, we have other alternative for systematic problem solving approach. I think from this TRIZ presentation, thank you, Dr. Risdi. So everyone, all students, please drop a question on the chat box if you'd like, and to respond about what Dr. Risdi has already presented. Thank you. I will invite all students and all colleagues, all lecturers, professors, please. We will still have 30 minutes for discussion. If I may highlight one point about the approach, it's very interesting to solve problem without too much generalization or being no compromise for the subject. Yeah, for the subject. Pak Ilya, maybe you may respond to the presentation.
Yeah.
Thank you.
Thank you, Pak Risdi, for insightful presentation. And exactly with this kind of approach, and also in order to increase the creativity, from my point of view, looking at the project that and also the result of the initial design, we still have the problem of lacking creativity based on the hackathon we did on Monday. So I do really hope that the original solutions, such as dynamization or maybe segmentation, can be used to create architectural solution for your design, your project. So and Pak Risdi has already given you a roadmap to achieve that quality of maturity in design with a very systematic way, which is to some extent one of the strength of UII, but also maybe at the same time become a witness of the UII student. Why? Because it's, if this systematic way is too stiff, then the creativity will not come because too afraid to think in other way. But Pak Risdi has already given us the tools to do to increase the creativity and in the very systematic way. So I think this is a very good combination, and also very good opportunity for the student to push themselves in order to have the original solution for their problem. Thank you, Pak Risdi. And please, I think this is the very good opportunity for the student to raise question or maybe to raise opinion regarding this TRIZ method.
Yeah, thank you,
welcome,
Dr. Ilya.
Yeah.
Yeah.
If
Indeed.
there is no question, maybe I can share some example of my student work. Okay, so that maybe you can get some idea. Okay, let
Thank you, Pak
me
Risdi, please.
share this one. So this is the example of a smart furniture idea. Okay, and this is done by my student. Okay. This is a example, and then of design. Okay, and then my student also make the real one based on this design. So this is the real product that he made. Okay, so based on the design, and then he make the real product. Okay, this is the example. Okay, so this table has 4 mode. Okay, the first mode is like this, so that you can use the chair. Okay, and then the second mode is the lower one. You don't need the chair. Okay, and then the third mode, with the chair but with extended table. Okay, and the fourth is the lower one without chair with extended table. So this is just example, and maybe I can show you another example here. Let me check. Yeah, this is also my project. Okay, my project related to wheelchair. Okay, you can see this, the wheelchair that you can control. Okay, and then this is the new feature. Okay, that the wheelchair can stand. Okay, this is the standing wheelchair. So the disabled person, okay, he or she can stand up, okay, by using this standing wheelchair. Okay, so this is the process of patent, okay, because in Indonesia we don't have this one, and some feature will be patented. This is from my work, okay, using TRIZ method. Okay, and then maybe yeah, this is another principle. Yeah, I like these things. Okay, copying. You can copy some, for example, usually if you have spouse and then you always sleep with him or her. Okay, and sometime he or she go out and then you cannot sleep. You can have the copy of him, the copy of her. Yeah, this is copying. It's very similar. I think these two are very famous, right? Okay. The left one is a movie star. Okay, and the right one also movie star. Okay. Yeah. And the explanation of parameters and for the inventive principle can be found at this. Okay, just go to this website and you will get very interesting material related to TRIZ, triz40.com. Okay. And if you want to know more in UK, you can go to Oxford Creativity, triz.co.uk, and you can get the training also here. Okay, it's very, very good place to learn about TRIZ. But if you think the price is not affordable, okay, you can contact me to get the similar training with the lower budget. But if you want to go to UK, not only for studying, but also for leisure or something like that, yeah, it is better to go to UK. Okay. Where is the position of TRIZ? For example, if you use design thinking, this is, I think we use also in architecture. Okay. The TRIZ position is in idea. Okay. So in idea, start generating the idea. So how to generate idea? In many cases, we have no clue. Okay, but by using TRIZ, maybe there will be some recommendation. In product design, TRIZ in product generation. To generate a product concept, this is the position of TRIZ in product design and development. Where the position of TRIZ is powerful is here in problem formulation and search for ideas, concept and evaluation, and so on. So we have to complement these TRIZ with other method. For example, TRIZ is not good in market research because the function of TRIZ is not for that one. Not also for example, DOE or computer modeling and so on, because TRIZ is the part that some of others method is lack, especially for search for ideas. You can see it here. You can instead of TRIZ, okay, you can use trial and error or morphological analysis or synectic or focal object, yeah, or brainstorming, okay, or red hat, and so on. Okay, or Osborne checklist. There are so many tool to generate ideas. Okay, but TRIZ is one of them. Okay, and which companies use TRIZ? You can go to Google and just write TRIZ Samsung, and you can see that many article related to TRIZ in Samsung. Okay, what makes Samsung such an innovative company is Forbes. You can go to Forbes.com. Okay, and here we can see that Samsung had early success with TRIZ, yeah, saving over $100 million in its first few project. It was also adopting Six Sigma, but it was TRIZ that became the bedrock of innovation at Samsung. Okay, and it was introduced at Samsung by Russian engineers, whom Samsung had hired into its Seoul lab in early 2000. And now TRIZ has become the obligatory skill set if you want to advance within Samsung. Okay, so the company that have the highest number of TRIZ practitioner is Samsung. So in Samsung, there are all the engineers in Samsung, they use TRIZ as a medium for communication. So for example, in engineering drawing, we have engineering drawing as language, as communication. In Samsung, they use TRIZ as communication. These some companies that use TRIZ, I do believe that okay, Rolex, Christian Dior, okay, Seagate, Schneider, Siemens, Intel, and so on. P&G, Whirlpool, Kimberly-Clark, okay, Oral-B, Unilever, Caterpillar. I do believe that you know all these symbol here, the logo. How about in TRIZ? Yeah, in TRIZ we have in our university, okay, in Islamic University of Indonesia, and currently I am the founder and the president of INTRIZ. Okay, so we have intriz.org, okay, and we have here many of lecturer has passed through level 1 training and certification. I do believe here we have Pak Arif, okay, Bismadi, and Bu Sukini, and so on. And here we have training center at Kauni, okay, UII training center, and we conduct TRIZ level 1, level 2 here. Okay, we have training certification also in this training center. Okay. And we have also in-house training. This is many. Okay, this LPGK, Yogyakarta, and this is our neighbor university. Okay, Andalas University, and also this Gajah Mada. Okay, Gajah Mada Mechanical Engineering. I was graduated from Gajah Mada, and this is some of my lecturer, okay, my senior here, okay, and also electrical engineering, Gajah Mada University, and Suranari University of Technology in Thailand, and Rajamangala University of Technology also in Thailand. And last time we have Smart Solution Project in Skede, Netherlands. Okay, this is some of students who learn at the time, and yeah, this is some situation that I adopt, how they make the group and then solve the problem together. And this is not only from one department, but a combination on not only for engineering, but also for economic, for law, for medical, and so on, become one team, and they solve the problem together. Okay, and this is just introduction to TRIZ, in TRIZ, and this is the project that we have done in Netherlands at the time, how to make a better live straw, okay, because we have contradiction here for the live straw to filter the water, okay, because if we go to Europe, all the faucet there provide the clean water, you can drink directly from the faucet. But if we go to the mountain or something like that, you have to bring your own water. Okay. If you want to drink directly from this water, natural water, you have to use the filter. And this is the filter. And we have contradiction here, because the membrane has pore here, has you can see here, the membrane has the pore, and the size of the pore should be small so that the microba, okay, the parasite, okay, cannot pass through, okay. But if the smaller the pores, it is more difficult to suck, okay. If we make the pore become bigger and then easy to suck, but but the parasite bacteria will not be blocked. So how to improve the design of this one? Okay, and the important thing is that what the industry said to us. Okay, the industry said, don't think about the technology, just think about the solution. Okay, don't think about how to make it, just think about the idea, because industry need fresh idea from university. Industry will think how to manufacture it, but industry need the help of university, the idea. Okay, even the craziest idea is accepted. Okay, and we have many ideas how to improve this live stroke, and the industry also happy because they have some new idea, even though we don't know they can make it or not. But this is the important thing that I want to share, that actually TRIZ can be implemented in many areas. Okay, this is for project in NSKD. Okay, and I also present my paper in many occasions. This is in the UK, ICDC, International Conference on Design Creativity, and some of the paper that I wrote. And we also become the winner of my TRIZ competition in 2018. You can see your hero here, Arif, I mean, not me. Okay. We were the winner. We got the grand prize in 2018. We got ringgit Malaysia 3,000 at the time. And this 2020 we have another competition, but we did not participate because of the pandemic. And in 2022 we will have competition also, TRIZ competition in Yogyakarta, because we will be the host of the competition. And I will be very happy if you can participate in that occasion next year in Yogyakarta. We will collaborate with Bapeda Yogyakarta. I have talked to Bapeda and they agree to collaborate with us to have international event. Not only for Indonesian, hopefully we can get the grand prize also. I do believe if you participate, and then you will be one of them, one of the prize receiver. This is the, yeah, I think that is the what we have done. Thank you very much. If any question, please feel free. You can contact me in this email, or maybe WhatsApp, or IG, or maybe Twitter, up to you. Okay.
Okay, thank you, Dr. Risdi. Yeah, it's very insightful, even more insightful after you share the later presentation. So there's one question from Mas Muhammad Imron Effendi. There's still time for us to discuss if you'd like. Thank you, Mas Imron, for dropping the question in the chat box. Mas Imron asking if I have, sorry, he has a question about does TRIZ work in other areas beside technology? Okay, while in the presentation before, there is an example like Iron Man costume, etc., in a technological perspective. So maybe he's asking about the interdisciplinary application of TRIZ. Maybe Pak Risdi would like to answer about that and have a discussion about that. Thank you, Pak Risdi.
Okay, so thank you. Yeah, thank you, Mas Muhammad Imron Effendi. Okay, so that's very interesting question, and I have been questioned this many times, and now I understand that TRIZ actually originally for engineer. Okay, originally. Okay, let me stop the share. Okay, originally, but okay, now TRIZ has been implemented in many areas, including in management. So not only for engineering, okay, even for psychology. Okay, for example, when we talk about pressure, that is too mechanical, right? Pressure is too mechanical. But actually, if we use a pressure in management, maybe that's related to the pressure for the worker. Okay, if we talk about the flow, for example, in mechanical engineering, the flow may be about the flow of fluid, okay, the flow of energy, and so on. But that's also a flow of money in the bank. So also in bank, we can apply the TRIZ also. Even for service, okay, for example, if you go to the bank, okay, before when you queuing in front of the cashier, okay, sometimes there's a problem because one cashier might be serve a very long time, okay, and other classes very fast, and so on. Now you can see that no need to queue, because when you enter the bank, you can get the queuing number, okay, queuing number 1, number 2, and so on. And which cashier you want to go is not assigned yet, okay, but based on your number. So this is very much better, okay, compared to the previous one. And this is the flow, okay, the flow of people in the bank. Let's compare to the flow in mechanical engineering is different. In mechanical engineering, flow means that the flow of water, flow of the energy, flow of the metal, and so on and so on. When we talk about load, the load in mechanical engineering related to the force, the moment, torque, and so on. But when we talk about the load in the maybe industry, or maybe in company, or in like that, we say that the load is the workload. When we talk about the load for student, is the load of the maybe homework, the load of the assignment, the load of something like that. So TRIZ actually can be implemented not only in engineering, but also in all the areas. Even though when I gave the training for all the lecturer at the time, that was Pak Nurholis, Pak Nurholis, not Pak Prof Nurholis from architecture, but Dr. Nurholis from Faculty of Religion. Okay, and he said that wow, this TRIZ is quite similar with what we learn in Hadith, in fiqh, because in fiqh we have a principle of fiqh, okay, and so on. So, actually, TRIZ also can be applied in how to we use fiqh, because with fiqh we have usul fiqh, and so on and so on. At the time, I was surprised, because Pak Dr. Nurholis said that, we can apply TRIZ also in Faculty of Religion. And informatics, there are so many things in informatics that are related to TRIZ, and we have one of the in TRIZ founder is from informatics. So I do believe that the TRIZ can be implemented in many areas, including in our family. Okay. Yeah.
Okay, thank you, Pak Rizdi. There's one question from Pak Sparwoko. Maybe this one is quite technical.
Okay.
Woko, thank you for asking. Is it possible the TRIZ training to be delivered by online classes, and how long the TRIZ level 1 is to be taken?
Okay, so
The
thank
duration
you, Dr.
maybe. Okay.
Suparwoko.
Yeah, please, Pak.
Yeah, last time I have presented this presentation also to Magister. Okay, and the time Pak Woko invited me, okay, to introduce TRIZ for Magister. Yes, Pak Warwoko, of course, I have host the training online with let's see this one, but I'll show you this one. Wait. Andalas. Yeah, this one. Okay. Yeah. Can you see my slide?
Not yet, Pak Rizdi.
Not yet. Oh,
yes.
Sorry. Okay, so share screen. Yeah.
Yeah, it's already seen. Thank you.
Yeah. Okay. So this is in-house training Andalas University in 2019. Okay, at the time, we conduct the training, of course, before a pandemic. So this is offline. So I went to Padang, and then we conduct TRIZ training for mechanical engineering lecturer. There are some professor here, okay, and then they were interested to take level 2. Okay, but level 2 in 2020 when it's impossible to do offline. So I could not go to Padang because of pandemic, and also due to the regulation, it is not impossible to conduct TRIZ training offline. And then we try to have a level 2 training online. And that's quite interesting because we successfully conduct training for level 2 for Andalas University, but we divide the time into 4 days, usually only 2 days, okay, from morning to evening. But because online is quite difficult to conduct 1 day in front of computer is very exhausted maybe. So we conduct training from 8 to 12, okay, or for 8 to 1 o'clock, okay, 4 time. So every Saturday and Sunday. So Saturday, Sunday, and then the next week, Saturday and Sunday. So total the same hours, okay, with the 2 days training. Um, yeah, it is possible also to conduct TRIZ training online. So how long the TRIZ level 1? Yeah, that's 2 days. But if you want to, maybe it is easier to say 18 hours, okay, 16 hours. Easier to say 16 hours, 16 hours. Because a day is 8 hours, so 2 days it should be 16, sorry, 16 hours.
Thank you, Dr. Risti. It's very technical, but yet it's very important for us to know. Okay. And then there's a question from our lecturer, Pak Aryadi. He's asking, architectural design aspects do not only solve problems related to functional and technical aspects. Often symbolic aspects such as metaphors, analogies, etc. are are often used to provoke design creativity. How the trees can play a role in the symbolic aspect. Okay, something that is very symbolic. Okay, is there
this is
any idea?
Okay, so the question is not in the chat, right?
Yes, it's on private chat. Maybe I will share.
Okay.
Maybe I'll share on the public chat. Okay.
Okay. It's possible to share in the public. So yeah.
Yes.
Okay.
Yes.
Yeah, I do agree with this statement that architectural design aspect do not only solve problem, okay, related to functional and technical aspect. Yes, of course. Okay. So like what I said before, that TRIZ is just complement. Okay, some of the thing that TRIZ cannot do should be done by other method. Some that TRIZ can do, maybe TRIZ can have function there. So actually, I'm not sure about the scope of architecture because I'm not, my background is not architecture, but maybe some of the tool, okay, that TRIZ can help, maybe TIS, yeah, trend of engineering system evolution, okay. So the basic of TRIZ is to improve the ideality, okay, to improve the ideality. In architecture, also the building become more ideal and more ideal. For example, the ideal building is that the building that not consume electricity more, right? What we call green building. Okay. So what is the ideal building? The ideal building is the building without light in the daylight. Okay. But this is the ideal because in the daylight, we don't need the light. We have the sun, for example. And this ideality is one of the important aspect in TRIZ. So if we know the concept of ideality, okay, we know about the concept of trend of engineering system evolution, or TESE, okay, you can find out the meaning of trend of engineering system evolution here, and how to improve the ideality, okay. So sometimes metaphor and then analogies, okay, we use also in TRIZ. in TRIZ we have smart little people. Okay, this is about analogy. Smart little people. Maybe you can use this as a keyword. Yeah, smart little people in TRIZ. Okay, that's analogy. So, for example, if we have the stove, okay, and then we have problem with the stove when cook, okay, or maybe you want to cook the water, okay, and then the kettle cannot inform us, okay, about the water already boiled or not, okay, and then the TRIZ will imagine you are a smart little people, okay, what will you do in this case, okay, and then we will imagine that there are very small little people, very small around the stove, and then what will they can do, okay, maybe the smart little people say, oh, I will shout, okay, I will shout, and then meaning that we will design the kettle that can make a voice, okay, like yeah, voice, something like that, to give us the sign that already boiled or something like that. Or maybe the smart little will say that, oh, if I become a smart little people close to that stove, I will turn off the stove, okay, and then what we can do, we can use the automatic switch, okay, if the water already boiled and so on. That is also metamorph and analogy. We use analogy also in TRIZ, but that is just additional tool, not the primary tool. Okay, so the creativity in TRIZ not only by using very systematic, yeah, like what we have seen, systematic. This become like algebra, okay, but also by using asystematic, by using analogy, by using metamorph, and so on. Okay.
Okay, thank you, Dr. Risti, for the response and the discussion. I think it's very interesting how we can learn from trees and from other approach for problem solving. That, yeah, there's the systematic and asystematic method to do that. So maybe we still have to analyze, and then we still have to conclude, and we still have to decide what kind of parameter or what kind of keyword that we will use, either if you use TRIZ or other approach, right, Dr. Risti? Hopefully that will conclude all. Or maybe is there any response from Pak Ilya?
Yeah. Design is not only about problem solving, but in every design, it should be, or maybe the biggest problem is that problem solving itself. So, sorry, design is also about the delight of how that solution is beautiful, or something like that. So, and it is part of the job of designer to make it optimum between the value of this delight and also the value of the solution of the problem. So I think Pak Risdi has already given us the spectrum of this problem solving, and it is the task for architecture to use that as part of our way of thinking in creating the solution, and to make it more complete, but at the same time giving us also the opportunity to the more space and more time to deliver that solution in more valuable states, meaning that it is not only about the solution, but creating more value in various contexts and also various level of interpretation. I think, thank you, Pak Risdi. We do hope that we, all of the students can learn from you. Thank you.
Thank you, Pak Ilya, for the response. Okay. Okay, all guests. And for Pak Risdi, thank you, Dr. Risdi, for giving us insights and inspiration to do all the architectural design studio process. Okay, there's a chat from Pak Gali Gunagama. Very interesting presentation. Wow, what a good quote. Thank you, Pak Gali. So it was a very fruitful discussion for us and a very insightful presentation. But unfortunately, we have to close the discussion session right now. And after this,
sorry, Leah, I forgot to mention that Pak Risdi has shown us the activity in NCD. Actually, the design of this hackathon is something like this, something like yes. As Pak Risdi has shown us with the NCD activity. So yeah. Maybe next year when the pandemic is over, or we can cope with the pandemic with the vaccination, etc., we can do the hackathon in real hackathon. Yes. And also maybe inviting again Pak Risdi to do the hackathon in the in campus. And this is the very interesting activity, hopefully. I think. Yeah.
Yes. Thank you, Pak Ilya. So we'll invite Pak Risdi next year, inshallah, after the
and with Pak Arif.
Yes. Thank you, Pak, for the confirmation. So yeah, and then. Okay, after this, so thank you, Pak Risdi, once again. After this, let's have an Asar prayer, and then after that, let's join the parallel class for all UII ADS2 students. Maybe each lecturer has already shared the link on the Google Classroom, so please follow the link to join the class after that. Thank you, all of students and all lecturers, and especially Dr. Risdi, once more, I please give a round of applause virtually.
Thank you, Pak Risdi.
Thank you, Pak Risdi.
You're welcome, sami-sami.
So, yeah, thank you all of us. Let's close this session with reciting Hamdalah. Alhamdulillahirabbil alamin. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.